All right, kids, I'm going to do just show you what an arc is. So let me zoom up a little for you. So if I draw a circle, no, that's not going to do it. That's better. Okay. So an arc. This is an arc right here. Do you see that? It's just part of a circle, or part of the circumference. Okay. Now, since I'm here, may as well show you what a sector is. So there's another circle, and then I'll do a sector, which is, come on, part of the circle. So we can kind of shade that in. This would be, ooh, multicolor. Ooh, look at that. It's magic. That would be a sector. Okay? Now we have formulas, so let's get those out of the way. To find the length of an arc, formula would be, let's just call it theta over 360. Okay, remember theta would be the measure of the angle, or in this case the arc, and then you just simply multiply that by 2 pi r. 2 pi r represents the entire circumference. This right here represents the part, or the fractional part of the circumference. Okay, so if we come down here, area of a sector, you guessed it. Let's get a different color, bigger. Theta over 360 times pi r squared. Pi r squared gives you the area of the entire circle, and then this is the fractional part that you're looking for. Okay, I did that in the last example, but I'll leave the rest for you. Let's come down here though. These are kind of cool questions. 90A. If you look in your book, it's got a 30-degree angle or 30-degree arc and a radius of 3. Okay, so we could figure out the length of that arc. How do we do it? Well, if we take 30 over 360, multiply it by 2 pi r, and to save some time, the radius is 3. Okay, so let's just, can you see that 30 goes in once, goes in 12 times? And then, well, 2 times 3 is 6. So we're left with 6 pi over 12, but that reduces to pi over 2. 6 goes in once, 6 goes in twice. Okay, how about the other circle with a radius of 5, but still with that central angle? So check this. I'm going to come in with this. This is my new little toy. Check this out. Cut it out. Done. Okay, so if we take 30 over 360, again, oh, I should have saved time and said that was 1/12, times, oops, times pi 2 pi, that's terrible, let me erase, times 2 pi radius of 5. Again, this, now we learn that's 1/12. Oops, I hit it with my hand. That's 1/12. This is 10, so we're left with 10 pi over 12. And then we can reduce it to, that's not, is that right? Yeah, 5 pi over 6. Okay, so next question. It says, this is where the magic happens. For circle D, what's the ratio of the arc length to the radius? Okay, arc length to the radius. Well, if you recall, the arc length was pi over 2 to the radius, which was 3. Okay, now don't dial 911. Remember, put this over 1, put an equal sign line, it bails you out, multiply the outers, multiply the inners, and we get pi over 6. I'm going to leave that because we're going to need that here in a minute. Okay, but let's zoom over to the next question, C, which wants for circle E, do the exact same thing. Okay, so we can do the exact same thing. In this case, though, it was 5 pi over 6 over the same radius. Let's put the radius over 1, equal sign line, outers over inners, and that doesn't feel right. What did we do wrong here? Oh, radius was 5. Look at, we don't have to panic. Let's just get the eraser out. Oh, see that? We can just put in a 5, no big deal. So this, now we gotta erase this. And then 6 times 5 is 30. See, I knew it didn't feel right because, check this out. I knew it had to reduce to pi over 6. Pretty interesting. Let's slide over here because now they say, what if you had a circle 30-degree angle and the radius was a hundo? Well, it's the same gig here. Well, first of all, we got to figure out, using our formula, times 2 pi r, and in this case it's 100. So this is going to be a little more work. Again, we've already established this is 1/12. Okay, this is 200 pi. Can I just change that to 200 pi? Okay, now we can slide this over. 2 goes into top and bottom, so 2 goes in 6 times, and 2 goes in 100. Oh, so 2 goes in again 3, 2 goes in again 50. You got the fraction calculator, you can do it that way as well. You could have just done 2 hundo fancy button 60. You'll get the same answer. Okay, so there is the length of that arc. Now let's see the ratio of the length of the arc over the radius, which this case was a hundo. Okay, let's put this over 1, equal sign. I'm just going to slide over just a little, give us a little more room. Equal sign line. That's 50 pi. Yeah, can you see what's going to happen already? Over 3 hundo. 50 goes in once, 50 goes in twice, pi over 6. We get the same ratio every single time. I want you to think about that. It's all going to make sense shortly. Until then, take a break.